All right, assalamu alaikum everyone. I hope you guys are doing well. Can someone please confirm if you can see my screen?
Yes, sir.
All right, good. Thank you. Let's begin. So in our last session, we started quadratics, our first topic in paper one. We just reviewed some of the concepts that you already know from your O-levels. This was the first thing that we did. We learned how to solve quadratic equations. It was just a quick review of the two methods that you've done in O-levels, midterm breaking and using the quadratic formula. What's important to remember here is when you are solving quadratic equations in paper one, M1 or S1, you always have to make sure that you at least show this step when you are showing the working for quadratic equation, the step in which you're factorizing, and the step in which you're showing the factors, or if you're using the quadratic formula, at least show this step in which we're inputting values in the formula. At least these steps are important. After this, you can write down the answers. If you write down the answers directly without showing these steps, you don't get any marks for that. Okay, so please make sure that you remember that. That's what we learned. Then we talked about what these solutions mean that you get from solving a quadratic equation. So when you solve a quadratic equation, you get some values of x that satisfy that equation. These values of x, what do they mean? Algebraically, they mean if you were to input these values in the function, in the equation, they will satisfy the equation. And also graphically, these values represent the x-intercepts of this function. The function that you've got on the left side of the equation, y equals 4x square minus 3x minus 10. If you were to draw this function, the values of x that you're getting here, they represent the x-intercepts of the graph of this function. All right, that's what we did. Then we talked about graph of a quadratic function. There are two possible shapes, U-shaped or an N-shape. We said they have a line of symmetry and they have some turning points. They have one turning point, each of them. We talked about other names that you've got for the turning point, vertex and stationary point, and we learned how we figure out which of these two shapes we get. When the coefficient of x squared is positive, we get the U-shaped graph, and when the coefficient of x squared is negative, when this value of a is negative, you get an N-shaped graph or an inverted U-shape. All right, so that's what we did in the last session. Now, today, what we want to do is we want to first learn how to find turning points of a quadratic function. That's the first thing that we want to do in our today's class. Let's start from this thing. Turning point. How do you find the turning point of a quadratic function? Now, let me just write it down first. Finding the turning point. Now, this turning point could be a minimum point, like in the case of the U-shaped curve, or it could be a maximum point, like in this second case, in the case of an N-shaped curve. Now, how do you find this turning point? Let's understand that using an example. Let's say I've got a function that looks something like this. Y equals 2x squared plus 12x plus, let's say, 15. So I've got this function. All right. Now, what is the shape of this graph going to be? We look at the coefficient of x squared. That's positive. So it's going to be a U-shaped graph. This graph is going to look something like this. All right. Now, we have a turning point of this graph. That's right here. We are looking for the coordinates of this turning point. Okay. Now, if that was the only thing that you wanted, if you wanted to just find the turning point of the graph, this is what you could do for that. Remember, the standard form of a quadratic function is this: y equals ax squared plus bx plus c. This is the standard form for a quadratic function. If you were to find the turning point of this graph, all you have to do is you can just use this formula: x equals minus b over 2 times a. What this is going to do is it's going to give you the x coordinate of the turning point. Now let's try that. This is the function that we've got. In place of a, we've got 2. In place of b, we've got 12. And in place of c, we have 15 here. Okay. These are the 3 numbers that we've got. We only need a and b, in fact. So let's just focus on them, a and b. What's the x coordinate of the turning point? X equals minus b. The value of b here was 12. So that's minus 12 divided by 2 times a. The value of a is 2. And this gives us x equals minus 3. This is the x coordinate of the turning point. So now we know that the x coordinate of this point is going to be 3. How do you find the corresponding y coordinate? For finding the corresponding y coordinate, all we have to do is just input this value back in the function, and that's going to give you the corresponding y value of the function. Let's see what that is. Y equals 2 into minus 3 whole squared plus 12 into minus 3 plus 15. If you simplify this, this gives you 2 times 9, that's 18. Minus 36 plus 15. And you can see what that turns out to be. I think it's minus 3. 18 plus 15. That's 33 minus 36, right? It's minus 3, I think. Okay, so y value also turns out to be minus 3 in this case. Sorry, when x 3 लिख दिया था पहले, this should have been minus 3. Value of x. Y coordinate also turns out to be, just by coincidence, minus 3. Okay. So what are the coordinates of the turning point? They are minus 3 and minus 3 in this case. Okay. This is how we can find the turning point of any quadratic function, minus b over 2a. All right. Now let's quickly try to make sense of why this is working. Remember the quadratic formula? The quadratic formula looks like this: x equals minus b plus minus square root of b square minus 4ac divided by 2 times a. That's what the quadratic formula is. If you were to break it down into 2 parts, it gives you minus b over 2a plus minus square root of b square minus 4ac divided by 2 times a. Basically, the quadratic formula gives you the x-intercepts of the quadratic function. So if the function looks like this, you basically get these coordinates, these points from the quadratic formula, this point and this point. Turning point is right in the middle. Since the curve is symmetric, the turning point is going to lie exactly in the middle here. This is going to be the turning point. So it's exactly in the middle of these 2 points. Right? Now, this quadratic formula basically works like this: minus b over 2a. This thing gets you to the center of these two x coordinates. So basically, minus b over 2a gives you this point. And then when you do plus something, it takes you to this x coordinate. And then when you do minus something, it takes you to the other x coordinate on the left side. So this part basically takes you from the center to the right or to the left. Since in this case, we are only looking for the x coordinate of the turning point, we just get rid of this part of this formula and we just focus on this part minus b over 2a, and that gives us the x coordinate of the turning point. All right, so that's where this formula is basically coming from. That's a way to remember this formula as well. Just look at the quadratic formula. You know, the quadratic formula looks like this. We have done this before. This is the quadratic formula, minus b plus minus b square root of b square minus 4ac divided by 2a. What you can do is just look at this part, minus b over 2a, that is going to give you the x coordinate of the turning point. All right. And once you have the x coordinate, finding the y coordinate after that is pretty straightforward. You put that x coordinate back in the function, whatever function you have, you will get the corresponding y coordinate from that as well. All right. So this is one way of finding the turning point, the coordinates of the turning point of a quadratic function. Okay. This is where this formula is coming from. This is one method, minus b over 2. Okay. Now let's look at another method for finding the turning point of a quadratic function. Let's look at that now. And that is completing the square. You've done this before in O levels as well. We're going to quickly go over this whole process and try to do that. Try to find the turning point using this method as well. Now you need to know both of them. Completing square is necessary in any case, even if you understand this first formula, and you might actually like this more as well because it's much quicker. Sometimes they specifically ask you to complete the square for a function. All right, so they don't ask you for the turning point, because if they ask you for the turning point, you could just use this formula directly and find the turning point. So sometimes specifically ask you to complete the square, and then you have to do it. Right? Even if you know the turning point already, you will sometimes need to complete the square anyway. So you have to know this process that we are just about to discuss. So the second method that we've got here is completing the square. Completing the square method. Let's think about this now. Now, this was the function that we had above. I'm going to just slightly change it and make it, let's say, y equals 2x squared plus 12x. It was plus 15 there. Let me make it plus 25, let's say. There's a reason why I'm doing this, because I was getting the same coordinates, x and y, earlier. I just want to make sure that you are not confused which one is which, because they're both equal in this case. So I'm just making sure the coordinates will turn out to be different this time. They're not equal to each other. So let's take this function. Try to find the turning point of this function using the completing the square method. Okay. Now, how does this process work? Let's think about this. Now, the first thing you do is so let me actually go through the process once, and then I'll quickly give you an intuition of why we're doing every step in this process. But eventually, you'll have to sort of remember the whole process. So make sure that you understand the steps very well that we're using here. The first thing that we're going to do is we're going to say take the coefficient of x square common from the first two terms. Take the coefficient of x square common from the first two terms. Now, it could be from all terms as well, that's okay, but it's going to be simpler to just take it from the first two terms and keep this constant term outside. Don't take common from that, but it's your choice. I generally prefer doing it this way. Just take the coefficient of x square common from the first two terms. Why? Because we want to make the coefficient of x square 1. You cannot have another number apart from 1 as the coefficient of x square. If you got another number, you need to take that common outside and make this coefficient 1. Okay, so let me just add it here as well. We need the coefficient of x square to be 1. So if it's not 1 already, you'll have to take that number common outside so that you don't have anything with x square. All right, let's do that. Let's do this first step and see what we get from that. So we're taking 2 common from the first two terms. 2 common, and then you have x square plus 6x. And outside, you've got plus 25. All right, so you take 2 common from the first two terms. Now what you're going to do is you are going to divide the coefficient of x by 2. So whatever the coefficient of x is, ignoring the sign, right now it's plus already, but even if it is negative, you just have to consider this number. And what you do is you say, let's divide this number, which is the coefficient of x by 2. That's the first thing you do. Divide the coefficient of x by 2. Then you square this number. Then square the result. So in this case, what's the coefficient of x? It's 6 right now. You divide 6 by 2, and then you square that number. What do you get from that? You get 3 squared. Okay, you're going to leave it in this form. You do not evaluate the square yet. The third thing you do is you add and also subtract this number. Inside the bracket. Now, what does that mean? You've got this function y equals 2 into x squared plus 6x. Outside, you've got 25. What you do is you have x squared plus 6x. So generally what you're going to do is you're going to leave some space after this in the previous step, and you have plus 25 outside. And in this space, what you're going to do is we're just going to divide the coefficient of x by 2. So divide 6 by 2, that gives you 3. Square that number, so that's 3 squared. You're going to add 3 squared here, but you can't just add something to a function like that. You also need to balance that by subtracting 3 squared from that. So you add 3 squared and you also subtract 3 squared. Okay. Now, once you're done with this, these first three terms, they are actually going to give you a perfect square. This is that form, a square plus 2ab plus b square. If you think about this thing can be written as x square plus 2 into x into 3 plus 3 squared, right? So this is a square plus 2ab plus b square. If a was x and b was 3, this is what you get. And this can be written as x plus 3 whole square. Okay. Now, you don't have to show this process every time what you've done here on the side. What you'll do here is you'll say, let's just take x from the first term. So you'll always do this. You'll take x from the first term, only the sign from the second term. So you take x only from the first term, only the sign from the third term, from the second term, sorry, and then the number inside the square from the third term. And that is going to give you a perfect square, which looks like this, 2 into x plus 3 whole squared. All right, you take x from the first term, plus sign from the second term, and 3 from the third term. That is what we are going to do here. All right, let me just color code this. So we have 3 square here. So x is coming from here. This sign plus is coming from here. And this 3 is coming from here. So we have x plus 3 whole squared. Now, we still have this number outside. We can't just leave it. So we have minus 9 outside. And then outside the bracket, we've got plus 25. And now once you're done with this, we just simplify this a little and multiply this 2 inside the bracket now. When we do that, we get 2 into x plus 3 whole squared. But remember, 2 also has to be multiplied with this number. That gives us minus 18 plus 25. And that gives us y equals 2 into x plus 3 whole squared plus 7. This is the completed square form. All right, this is the completed square form. This is what we were looking for. Makes sense? Any questions on this? Any questions on this process? So you have to remember this process. We'll discuss the logic of this very briefly in a moment, but let me know if you have any questions on this, if you understand this or not. You've done this in O-levels, just a quick review of that. Let me know if you have any questions on this. No problems? So you take the coefficient of x squared common, then you divide the coefficient of x that you've got here by 2, square that, you add that number and also subtract that number. Then from these first three terms, you take x from the first term plus the sign from the second term, whatever it is, plus or minus, and then this number from the third term. And that gives you a perfect square. All right, because it's that form a square plus 2ab plus b square. And then this is the number outside that comes right here as it is. And then you simplify everything and that completes the square. All right, now how do we find the turning point from this working? What's the turning point? Now, this is what the turning point is going to be. This is the standard form for the turning point of a quadratic. This is the standard completed square form. It looks like this. Y equals a into x minus h whole squared plus k. This is the standard completed square form. of a quadratic function. So quadratic function has this standard form, ax squared plus bx plus c. So this is one way of writing quadratic functions. Another way of writing quadratic functions is this particular form, y equals a into x minus h whole squared plus k. All right. Now, what does that mean? This number outside, this is a. This a is the same as this a that you have in this form. Okay, this is also 2. That's always going to be the same. Then you have a bracket in which you've got x minus or plus something. And then you have some number added or subtracted outside the bracket as well. Okay, so this is another form that we've got. This is called the completed square form. This is the standard way of writing this. If you've got something in this standard form, the turning point here in this form is h and k. This is the turning point, h and k. This is h and this is k. All right. HK are the coordinates of the turning point. Now, if you were to compare the standard form with what you have got, you see in the standard form, you've got minus h. You have got plus 3 inside the bracket. Now, what does that mean? That means minus h should be equal to plus 3. Right? Let me actually write it here. Minus h should be equal to plus 3, and that gives you h equal to minus 3. Similarly, if you compare the number outside, what's that? That's plus k. What you've got is plus 7. You equate both of them. Plus k equals plus 7, and that gives you k equal to 7. So the turning point of this function is hk, which is minus 3 and 7. This is the turning point of this quadratic function. So what we're doing is we had something in this form initially. We had y equals ax squared plus bx plus c. This was the expanded form, the standard form that we got for a quadratic function. What we did here was that we converted this to the completed square form, which turned out to be a into x minus h whole square plus k. In this form, the turning point is given by h and k. Turning point is h and k. All right. Now, one way to do this, one way to remember this is, okay, what the turning point is going to be. You can just do this thing. You can say, once you found this form, all you have to do is, whatever is the number inside the bracket, you're going to flip its sign. It's plus 3 right now. You're going to change the sign. It becomes minus 3. That's the x coordinate. All right. You just flip the sign of this number. Again, the reason is you've got minus h here. Since it's minus h and here you've got plus 3, they have different signs. So its sign is going to reverse here because minus is going to go to the other side, right? And it's going to change the sign there. Similarly, this number that you've got outside, it will remain as it is. So whatever this number is, this is not going to change its sign. It's going to remain as it is. So 7 is going to come down as it is. That's the turning point. Okay. Now, let me just write down some examples on this. So for instance, if you had something like this, 4 into x minus 3 whole squared minus 4, or let's say minus 5, what would be the turning point of this function? Let me have a heading here. We want turning point of this function. This is the function. And if you want to write the turning point there, all you have to do is flip the sign of the number inside. So it's 3. Keep the sign of the number outside as it is. That's -5. That remains as it is. Okay. Take another example. You could have -5 into x plus 2 whole squared minus 3. What about this turning point? Flip the sign of the number that you've got inside. So +2 becomes -2. Keep the sign as it is for the number outside. That's -3. Okay, so you change the sign of the number inside for the x coordinate. The number outside keeps its sign as it is, and you get the turning point from that. Make sense? Any problems with this? Any questions? This is how we complete the square for a quadratic function. And find the turning point from that. Okay. This is one way of doing this. This is one way of doing this. There's another method that we've got for this as well, for completing the square. Let's discuss that. And a lot of people find that much easier than this first method that we did here. You can also do that. But for that, you want to need to memorize a particular form. So if you can just memorize this form, a into x minus h whole square plus k, we can actually make this process of completing square slightly simpler, especially when you have some coefficient of x square here. Normally, when you have the coefficient of x square 1, it's not that difficult to complete the square using this method that we've just discussed. If it's already 1, you don't have to take anything common outside, and this process is much simpler. But if the coefficient of x square is not 1, like in this case, it was 2, then people end up doing a lot of careless errors here when taking this number common outside and then multiplying it inside again at the end. So that ends up being a problem. In those cases, we also have another method that you can use, and you might find that easier. Let's try and understand that method now. Okay, so this is one method for completing square. Again, you've done this in O-levels as well. We have just quickly reviewed that, but let's discuss another method for completing square, which I would recommend that you also try to understand well, because it makes things a lot simpler. Let's see how it works. So we've got y equals 2x squared plus 12x plus 25. Let's use that same example. 2x squared plus 12x plus 25. This is what the function was. All right. Now, what you can do is you can actually just use the first method for finding the turning point here first. All right. Find the turning point first and then complete the square using that turning point. So we are flipping this a little. In this method, what we did was we completed the square and then used that the completed square form to write down the coordinates of the turning point. All right. Another way of looking at this could be that we could find the turning point first. And that using that easier method that we did earlier, x equals minus b over 2a. Use that earlier method to find the turning point. X equals minus b over 2a. Let's use that and see what we get. So remember what this form is. This is y equals ax squared plus bx plus c. So if you were to compare the two, a equals 2 and b equals 12 in this case. So what is the x coordinate of the turning point? Minus b over 2a. B is 12, so it's going to be minus 12 over 2 times a. That's 2 times 2. That gives us x equal to minus 3. That's the x coordinate of the turning point. All right. Now, how do you find the y coordinate? We put this number back in this function and see what that gives us. Y equals 2 into minus 3 whole squared plus 12 into minus 3 plus 25. We simplify this and see what we get. So this is going to be 2 into 9, which is 18. 18 plus 25 is 43. 43 minus 36. This should turn out to be 7. Y equals 7. So what we do is we write down the turning point first. Turning point is minus 3 and 7. Now, if you remember the standard form, along with these signs, minus and plus, a into x minus h whole square plus k. Write that down here. Y equals a into x minus h whole squared plus k. This is the standard form. This is the standard completed square form. Remember what h and k used to be here? The turning point is h and k, right? This is what the turning point is. All you've got to do is input the values of h and k in this particular form. And along with a, of course, a is the same as this a here, that's 2. So that's all you've got to do here. You say, let's input a equal to 2. It's coming from this equation directly, this form directly. H equal to minus 3 and k equal to 7. Let's input those values here. That gives us y equals 2 into x minus 3. You've got minus here, and then h is minus 3, minus 3, that becomes plus 3 whole squared, plus k, the value of k is 7, plus 7. And this is your completed square form. And that's exactly what you got from the other method as well. 2 into x plus 3 whole squared plus 7. But now you don't have to do all this algebra that we did here. And that saves you from some careless errors. If you find that easy, you can also do this. You find the turning point first. You can just remember this particular form. Y equals a into x minus h whole square plus k. Just input values in this form, and that's going to give you the completed square thing directly. Okay. Here, everyone. Any problem with the anyone? No questions? Can I have some response?
Sir, I had a question.
Yes.
Sir, if in the question they specify that we need to solve a quadratic equation using the completing square method, so whichever one of the methods that you just taught, if we use that, then we'll still get the method marks for it, right?
Yes, of course. Both are methods, so you can use either of them, doesn't matter. They have to use. They will just need the completed square form. You can do that using other method as well. As long as it's logical, it's mathematically correct, that's going to work. As long as you show you're working as well. So you have to show you're working. If that's correct, you'll get the method mark.
Okay,
All
sir,
right.
thank you.
Okay, so this is how we complete the square. Now, before we end, let's quickly have a look at one example in this. You've got the worksheet not uploaded yet. I'll upload the worksheet so you can start doing some questions from this as well. Let me just take a question from the quadratics worksheet. So I'll start uploading the worksheets now as well, because now you will be able to do some questions from the worksheet at least. Uh, More so after tomorrow's class when we discuss the discriminant thing. But for now as well, we can at least, do an example where we have to complete the square. Okay, let's do this. Question number 3. Let's have a look at this. All right, so this is question number 3 from the worksheet. It says express 2x squared minus 4x plus 1 in this form. Now this is the completed square form, right? Now remember, these plus minus are not going to make any difference. Sometimes they put minus here, sometimes they put minus outside. It doesn't matter. You just have to complete the square. All right, there's nothing different. You just apply your standard method and complete the square. Okay, so you have to express it in this form. That means completed square form, and hence state the coordinates of the minimum point A on this curve. All right, so you have to do 2 things. You have to complete the square and also state the coordinates of the turning point. Now, again, you could use any of the 2 methods that we discussed. Let's use both of them here, and then you can decide which one you would prefer. Let me use the second one first. Let's say you find the turning point using the method x equals minus b over 2a. Now, what does that give us? In this case, a is 2, and b is minus 4, c is 1. Let's input values in the formula, x equals minus b over 2a. That gives us minus into minus 4 divided by 2 times 2, and that turns out to be 4 over 4, which is 1. Find the corresponding y value. Y equals 2 into 1 squared minus 4 into 1 plus 1. And that gives us 2 plus 1, 3, 3 minus 4, which is minus 1. So we know the coordinates of the turning point now. What's the turning point? The turning point is 1 and minus 1. This is the turning point. Okay. Now, since we need to write it in the completed square form, remember the standard completed square form. It looks like this. Y equals a into x minus h whole squared plus k. Now, what's the value of h? H is this. This is k. So you say, let's input a equal to this value, 2, h equal to 1, and k equal to minus 1. Just input values in this function, in this form. You get y equals 2 into x minus 1 whole squared minus 1. This is the completed square form that we were looking for. All right. So we have the completed square form, and we have already found the turning point here as well. So this is the turning point. So we have both things here. All right. 1 and minus 1 is the turning point, and we've got the form as well. We could use the other method. Let me show that to you as well. That would look like this. 2x squared minus 4x plus 1. How do we start? Take the coefficient of x squared common from the first 2 terms. And that gives us x squared minus 2x inside. You're going to leave some space here and have plus 1 outside. Okay. Now, what do you do after this? Divide this number by 2, ignoring the sign. Divide 2 by 2. That gives you 1 squared. You add 1 square here and also subtract 1 square from this inside the brackets. By the way, there's a very common error that a lot of people do here. This, for some reason, put this thing equal to 0. You can't do that. It's not an equation. Nowhere in this part it says that you have to put this equal to 0. It's not an equation. It's an expression. All right. It's just an expression like this. You can't put this equal to 0. So please don't do that. You're just going to keep it as it is. And then what happens is these three terms give us a perfect square. So you've got x from the first term, sine from the second term, and this number from the third term. X minus 1 whole squared. Outside you've got minus 1. So that stays as it is, and plus 1. Now you multiply 2 inside, which becomes 2 into x minus 1 whole squared, then 2 into this thing. That's minus 2 plus 1. And that gives you 2 into x minus 1 whole squared minus 3. Sorry, minus 1. Okay, this is what we get. And that's exactly what we got in this case as well. So that's the function that you're getting there as well. Now, what's the turning point? Because now we haven't found the turning point here. So for that, we flip the sign of the number inside. That becomes 1. And the number outside keeps its sign as it is. That is minus 1. So the turning point, therefore, is 1 and minus 1. So this is using the other method. Again, you can do whichever of them you prefer. All right, that's how you find turning points of quadratic functions. Now, the second and third parts, we'll discuss them later. Let me just show you one question before we end. I'm not going to solve that right now, but remind me in the next class. We will start from that, because that's a slight variation of the standard completed square form. Where's that? Yeah, this one. Now, slightly different. This one is slightly different from that standard form. We've got 2 inside the bracket here in this form that we've got. Okay, we'll discuss what to do with this in the next class, inshallah. But we're stopping here for today. I'll see you again tomorrow. If you have any questions, let me know. Otherwise, I'm going to end here. Any problems?